So our last piece here is looking at word problems for these piecewise functions. So typically with the piecewise functions, what you'll see in the wording of the word problems is that different rules apply for different scenarios. So that's where we're going to see these limitations to our domain and then our different ways of calculating things. So here we're looking at our electricity bill from an energy company, and it uses the following rates. So we have 5.124 cents per kilowatt hour for the first 250 kilowatt hours. So what we can tell is that 5.124 is only going to work for these kilowatt hours 0 to 250. After the first 250 kilowatt hours, it costs 6.899 cents. I'll do this in a different color for each additional. So what we want is a function to calculate cost. And what we're going to have here are two pieces. Basically, if we're in that 250 limit, or if we're going above the 250 limit. So, if x is less than or equal to 250, and actually we could just set those up now, it's actually easier to see our two domains. We have the case that x is less than or equal to 250. There's two ways to write this. We could write it as x is less than or equal to 250. Now technically, that would look like that we can plug in negative numbers. However, there's kind of this implied domain that we're not going to plug in negative numbers. It's not in there. So you could write it as x is less than or equal to 250. To be super accurate, we should really restrict it by 0 at the lower end and 250. So either way, really, like if we were graphing this, we would start at 0 because it's a word problem and we'd only have positive outputs. But if you wanted to really restrict it with accuracy, that's what we would do. And then our other case is if x is over 250. All right. So for the first 250 kilowatt hours, it's that 5.124 cents per kilowatt hour. So what we're going to do is take 5.124 times x. And that's how we would calculate our bill if the input's between 0 and 250. Now beyond that, it's 6.899 cents for each additional kilowatt hour used. Now, if I just did 6.899 times x, that isn't quite accurate. I don't know why I said quite. It's not accurate. It's wrong. And why that is because that's not the cost for the first 250. This is if we're going beyond that 250. So this is for the additional. So what we have is kind of this base cost. If you've used over 250, you have this 5.124 times those first 250 kilowatt hours. And then beyond that, then you're adding on this 6.899 for each extra one. So what I actually need to multiply with 6.899 is this difference between my total amount of kilowatt hours minus the 250. So what I'm going to do is adjust what I'm multiplying by here with that value of x minus 250, so that then I'm only seeing the extra number of minutes. And then what I need to add on is where this first function maxes out by plugging in 250 right there. So what I'll have is, and I didn't leave myself enough room here, but I would be adding on, in this kind of a long form, but 5.124 times 250. Sorry, let's make that small. So what this reflects then, and this we'll look at our next piece is plugging something in, and then we can really see how it calculates all together. What we have here is our first 250 kilowatt hours, and we're using that first cost. And then for each additional, So where we go beyond, so say I use 251 kilowatt hours, I would pay this base cost for those first 250, and then by taking 251 minus 250, I get that one extra kilowatt hour that I spent, and that gets the charge of 6.899. So let's see how all of this plugs in. Use the formula to determine the amount due when you use 325. So this is where we use the second formula because we've gone over 250. So we'll have 6.899 times 325 minus 250 plus 5.124 times 250. And we could have simplified the second piece. It would look better if we simplified that so that there's not extra work to do. But it's nice to see it separated so you know where those numbers are coming from. So 6.899 times, and I'm going to calculate that 325 minus 250, which is 75. So that's where I can see the 75 kilowatt hours over 250 plus that 5.124 times 250. So if I view it this way, I can see my total 325 kilowatt hours spent, but I get these two different charges for it. So then I would combine all that together, which would be 1,798.425. Now, keep in mind, it might be enticing to put a dollar sign there because that's usually what we work with when we're working with money. However, remember this is in cents. So it's not dollars, it's cents. That would be a very large energy bill. So if you wanted it in dollars, what we could do is divide that by 100. So really this is $17.98 if you wanted to use that format. So that's how we could think about our piecewise function in the form of a word problem.